All right, calculus, we're looking at right now U substitution part 2. Okay, so let's get started with the first one here. Remember, the questions that we're trying to answer, that we've been answering this whole time, is first we start out with U equals something, and then we have to break down the leftover, which has something to do with du and dx and a substitution with those. But there's going to be some constants and other terms involved in that. The first thing to answer then is this u. What's that the piece that we're going to pull out? We always like to pull out the inside piece, which in case this would be x to the 3 halves plus 2. So let's start with that. U equals x to the 3 halves plus 2. If I were to rewrite this integral, this antiderivative that I'm about to take, then I would have x to the 1 half times u to the 9th dx. So then what we're looking at here is I still need to somehow get rid of x to the 1 half and the dx. I got to translate those into a du. So how do I do that? Well, I take the derivative of my original statement here. So then I'm going to have du dx equals 3 halves x to the 1 half, then we got the plus 2 there. So the goal is I need to have, and we got this x to the 1 half dx, so I need to have this equals x to the 1 half dx. Well, I can multiply both sides by a dx and by the reciprocal of this 3 halves, which would be 2/3. So that gets rid of the 3 halves on that side and the dx on the other side. That means that 2/3 and a du will replace the x to the 1 half and the dx. So let's do that. Now rewrite this integral with 2/3 and a du. And we still have this u to the 9th, and the dx and the x to the 1 half are out. Okay, so now it's a pretty straightforward antiderivative. We got this 2/3 as a constant, so that'll remain the same. This function here is just a power rule. U to the 9th is now going to become u to the 10th, and we have to divide by that as well. And then plus c. Just to simplify things a little bit more here, this 2 and the 10 would simplify to 1/5. And then putting all the fractions together and substituting the u back in, I'd have 1/15 on the outside. And then u to the 10th is actually going to be x to the 3 halves plus 2 to the 10th. Because that's what our u originally was, up here. And then, of course, plus c. Alright, that wasn't too bad. Again, remember, the first question we're trying to answer is, what is u equal? The second question is, how do we deal with the leftover? So let's work our way through this one. Okay, now I got two pieces here, and it might not be exactly obvious. Sometimes there's even other algebraic tricks in here. But I see that I have layers. I got this inside and an outside. So I'm going to take that inside piece to be my u. So u equals x squared plus 4x minus 3. That would mean that this is the integral of x plus 2 times, we're going to have u to the 1 half, and then dx. That's 1 half came because it's a square root. So the pieces that I need to get rid of this time are the x plus 2 and the dx. Because the u is there, so I've gotten rid of that. Now I got to get rid of these other pieces. So how do I do that? I go back to my original equation and take the derivative. So I'm going to have du dx equals, well, the first term is going to be 2x plus 4. Okay, so a couple of things are actually going to happen here. First, I can actually factor this right side, and I need to because I need an x plus 2 and I need a dx. So I need something that's going to say x plus 2 times dx. like that. And the question is, what's on this other side? Well, let's start by multiplying both sides by dx. We can at least get that much over there. But then this has to be somehow x plus 2 times dx. Well, I can factor out a 2 from the 2 and the 4. Now give me 2 times x plus 2. Now I need to get rid of this 2 that's the coefficient out in front, so I'm going to multiply both sides by 1/2. Now it just says x plus 2 dx, and on the other side I'm going to have 1/2 du. So that's going to be my substitution for those two pieces. So I'll have the integral sign here. We got a u to the 1/2 from the first substitution. Then the second substitution is going to give us a 1/2 and a du. And now we're set. So I have 1/2 u to the 1/2 du. So taking the antiderivative, we're just going to add 1 to the power. That gives us u to the 3/2. We're going to divide by that number as well. And that's going to be times 1/2. And then plus c, plus our constant of integration. So now what we have here is, over that fraction, we got to do some simplifying there, because a fraction within a fraction really turns into 1/2, and then this 3/2 will be flipped times 2/3. Then we got u to the 3/2, so that's something cubed and then square rooted, and whatever it is for u. Well, what was u? Oh, it's bigger than that. I need more space. Not big enough. Need lots more space. So let's expand this out. And we said that's going to be cubed. So it's going to become, what was it? X squared plus something plus something. X squared plus 4x minus 3. And then these 2's over here would simplify. We got a 1/3, and that's it. Done. Oh wait, plus c. Now we're done. Let's look at the next one. Alright, now this is a little kind of tricky because we're looking at it and we're saying, well, what's x minus 4? And this says x plus 2. And the hard thing that really kind of trips us up is we got this square root and this x minus 4. And you want to find a way to somehow get rid of that inside layer of this double layer function. That means we got to do a substitution. So let's start with that, and then we'll get to the x plus 2. Okay, so I'm going to have u equals x minus 4. That would give me, if I'm going to rewrite this integral, the integral of x plus 2, and then we have u to the 1/2, and then a dx. So this is what I got so far. Now, it's not exactly obvious to you guys yet, but we're going to hit a bump in the road when we try to do the second substitution. So we have the du dx, if we were to take the derivative, just like before. It's going to equal 1, just that, and that's it. So then du equals dx. Now that's not a huge deal. I mean, that actually helps us. So this right here is just du. But the problem then is, what do I do with this x plus 2? Well, if it doesn't work with the du dx to make a substitution with the leftover, then go back and look at your first one. I want this to say x plus 2. Well, how do I get that? If I have 4 on this side, and I want to say x plus 2, well, I could take u equals x minus 4. But I wanted to say x plus 2, and in order to do that, I got to add 6 to both sides. It's just an algebra equation, you guys. It's I know it's not obvious to do this, but we just make it look like what we want. So u plus 6 equals x plus 2. So that's going to be going in right there for the x plus 2. Let's see how this looks in. So we're going to have the integral. We got a u to the 1/2. We got a du over here. And then we have a u plus 6. You might be saying, well, it doesn't look like it made that a whole lot easier. And it still did. So now there's only one layer with the square root. Whereas before, we had 2 layers. And double layers with integration is a little bit harder. You got to do a lot more thinking to get there. This is only one layer. And now the algebra is going to allow us to distribute this. We're going to have u to the 1/2 times 6 and u to the 1/2 times u to the first. So if I do this distribution property and simplify a little bit here, we'd have u to the 3/2 plus 6u to the 1/2 du. That's kind of tricky because we did like 3 substitutions there. We got, first we looked at the u to the 1/2. Then second, we looked at the dx and du were just equal, so that was easy. And then third, we looked at this x plus 2, which we had to do some algebra. This was our third substitution, using that same equation or its derivatives. Now that we've done all that, we're finally ready to take a derivative, or an antiderivative, I should say. So u to the 3/2 is going to become u to the 5/2 over 5/2. Plus over here we'll have 6u to the 3/2 over 3/2. And plus c. Now let's do some fraction simplifying and get that u out of there. That would give me 2/5 x plus 2. Or no, it's not x plus 2. It's x minus 4. X minus 4 to the 5/2 plus 6. What? 6 times 2/3 times x minus 4 to the 3/2, and then plus c. You can simplify a little bit algebra here. This becomes 4 times x minus 4 to the 3/2. This is 2/5 times x minus 4 to the 5/2. And we got plus c. Now, is there more we could do? Yeah, you could factor out some common pieces and work your way around from there, but for the most part, that's probably pretty good. Probably good there. All right, let's look at this next one. It's actually very similar. If you notice, we have x minus 6 here, and then the square root symbol out there. That means we got the double layer here. So that's our double inside-outside. So that's the inside piece that we got to start with. So this is going to be a integral of x minus 5 over square root of u and then dx. Now we can simplify that even more. We can say this is going to be x minus 5 times u to the negative 1/2 and then dx. Once we have it there, we can see that we need to get rid of this x minus 5 and this dx. So let's look at first what we have. If u equals x minus 6, then du dx is just 1, which means that du equals dx. So that's going to give us the dx to substitute. But we still need this x minus 5, so we got to reuse that u minus 6 again. So u equals x minus 6, but I wanted to say x minus 5. So what do I do in between there? I'm going to add 1. So that means that u plus 1 equals x minus 5. So that's my third substitution. The x minus 5 is going to come out, and it's going to be replaced with u plus 1. And we have u to the negative 1/2, and the dx comes out and becomes du. So now it's practically ready, but again, it's a little bit helpful if we distribute this outside u and make it individual terms. And we can do that now that we've removed this double layer from the first statement. We couldn't do that until now. So let's go ahead and do that. We have the first one is going to be 1 minus a half, so that's u to the 1/2. Then 1 times that is going to be u to the negative 1/2. du, of course, we're taking the antiderivative of that. That's going to give me u to the 3/2 over 3/2 plus u to the negative 1/2 plus 1 is just 1/2 over 1/2. So now let's do some simplifying. Got a plus c, of course. 2/3, and u in this case is x minus 6. Then we got plus 2 times x minus 6 to the 1/2. Excellent. Done. Let's look at the next one. Okay, not exactly obvious here, but it's kind of weird to look at this next one, number 12, and to figure out what is really the hard part. What's the part that's I want to see like what exactly is happening. Sorry, I got off track there a second. Somebody was trying to get my attention. But anyways, we got two pieces, and one of these is a double layer, and one is a single. And the double layer, that's the one that's going to have a substitution, our first substitution, because those double layers are problems for us with integration. And right here I see the double layer with x plus 1 and a square root. So let's start with that. We see that u is going to be x plus 1. So that means this is going to be the integral of x squared. And then we have over square root of u, and then dx. So a couple of things that we're looking at now. We got to figure out how to get rid of this dx and also how to get rid of the x squared. Let's start with the dx. Well, that's pretty easy because if we take this and take the derivative, du dx equals 1, so du equals dx. So that's simple enough. It's going to have a u to the, we'll bring this u up to the top, it'll be u to the negative 1/2 and dx. But now the problem is this x squared. What I want to do is figure out a way to get something equal to x squared. Now if I take my original equation, I'm going to have u equals x plus 1. I could eventually get this down to x squared. First thing I need to do is subtract 1 from both sides. I'd have u minus 1 equals x. Now for that to be squared, that's just u minus 1 squared. So this final part that's being worked out here is we'll have u minus 1 squared. Times u to the negative 1/2. Okay, so we got u to the negative 1/2 u, and then we got u minus 1, 2. This isn't easy to just distribute. We can't just distribute u to the negative 1 inside. We got to first do the squaring, doing like PEMDAS, order of operations, exponents before multiplying. So u minus 1 squared would be u squared minus 2u plus 1. So that means we're going to have the integral of u squared minus 2u plus 1 times u to the negative 1/2. And then the dx becomes a du. Now we can distribute this and do some more complex some complex algebra to set up the antiderivative. So remember, when you're multiplying same base, different exponents, you add the exponents. So 2 plus negative 1/2 is u to the 1.5 or 3/2 minus 2 times u to the 1 plus a negative 1/2 is going to be u to the 1/2. And then the last one is just plus u to the negative 1/2 because 1 times anything is itself. So now we're going to take the antiderivative of this piece times du. Now there's 3 separate terms there, so we can do each one individually. The first one, we add 1 to the power, we get 5/2. That's going to be over 5/2. The next one is going to be negative 2 times u to the 3/2 over 3/2. And the last one will be u to the 1/2 over 1/2. And of course, plus c. So now that we're kind of looking at this, we just need to do some simplifying. So the first one's going to have 2/5 something to the 5/2 minus 2 times 2/3 times something to the 3/2 plus 2 over 1 times something to the 1/2. And that something is the piece that we substituted, the u. So it's x plus 1 in each of those cases. And of course, at the very end, plus c. Alright, so for this one where it says cosine 4x dx, again, think about layers. And I see layers here. I see a 4x on the inside and a cosine on the outside. And that u is always that inside layer, so we can kind of work our way through that layer without even having to think about it. So if we say u equals 4x, let's see what happens. Then we're going to have the integral of cosine of u dx. We haven't gotten rid of the dx yet. So that means we got to somehow use this top piece to figure out what dx would be, because that's still left over. Well, du dx, the derivative of that original substitution, is going to equal 4. Now I want this to just be dx. In order to get it there, I would have multiply both sides by 1/4 and both sides by dx, and we get 1/4 du equals dx. So that's the piece we're going to be substituting now. So let's take this piece out, and we would get the integral of cosine of u, or the antiderivative of cosine of u, and then we got a 1/4 and a du. Now that constant out front, the coefficient, is just going to tag along, so we got the 1/4. Now we're looking for the antiderivative of cosine, and in this case, cosine, the derivative of cosine would be negative sine, but when you're going backwards, you're trying to figure out the derivative of what was cosine, and that's sine. So this would be sine of u, and then plus c. If we substitute back in for that u, we're going to have sine of, in this case, 4x plus c. Right, let's look at the next one. How many more do we got? We got quite a bit here, but now we're into trig, and trig goes faster than you would think. It's kind of weird. It just kind of runs through it because it follows the same pattern. So we have this thing here. We got sine on the outside and 1 minus 3x on the inside. So that's going to be our u, or that inside function. So u equals 1 minus 3x. So let's see what we got so far then. We're going to have 3 sine, and then inside here, this 1 minus 3x is going to be u. And then we got the dx still. So I don't really have to get rid of the sine, but I do need to figure out what to do with this, at least this dx. The 3 could stay there, but I need to figure out what that dx is. Let's see what we got when we take the derivative of the first equation. We'll have du dx equals -3. Well, let's go ahead and substitute this out. We'll get rid of this dx, move it over, and negative 3 down here. That would give me negative 1/3 du equals dx. So now I'm going to have the integral of 3, and then we got sine of u, and the dx becomes negative 1/3 du. Now some simplifying is going to happen here. This 1/3 and this 3 go away, but we still have that negative. So now we're looking for, simplifying even more, negative sine of u du. Let's see. We got to take the antiderivative of negative sine. So what, when I take the derivative, gives me negative sine? That would be cosine of u plus c. And in this case, u was 1 minus 3x, so this is going to be cosine of 1 minus 3x plus c. Awesome. Awesome. That actually went pretty quick. Let's look at this next one. Okay, a little quick rewrite. We got sine of x cubed, and then a cosine of x, and then a dx. So start simple. I notice that I have an inside-outside layer here, so I'm going to take my inside layer, which in this case is sine of x. U equals sine of x. That means if I were to rewrite this, I have the integral of u cubed, so I took out that inside layer. But then I still have a cosine of x and a dx. Well, let's see what happens when I take the derivative of this. Du dx is going to be cosine of x. If I just multiply both sides by dx, that actually gives me exactly what I need. That means that du equals cosine of x dx. So I'm going to take out this cosine of x dx and replace it with a du. That means we'll have, let's put it all together here. We're going to have the integral of u cubed from the first substitution. Then cosine of x dx is just du. Super easy. Super easy. So this will be u to the 4th over 4 plus c, which in our case, with what u is, that would be sine 4th, or pardon me, not sine 4th. I can't even think right now. Sine of x, oh, that would have been right. Sine of x all to the 4th power plus c, which in a multiple choice test would probably be written sine to 4th of x plus c. Done dizzle. Alright, we're starting to get a little loopy here. We got 4 more practice exercises. Okay, now I know what to do here because I recognize something, but I want to show you guys what's going on. So what I see, I see at least a matching inside piece. And remember that the u equals the inside layer. So in this case, it looks like that means u equals 10x. And then, just working a little bit further, that would mean that this is the integral of tangent u times secant u. We still have the dx, so we got to get rid of that. But we're pretty close. And this is a very doable derivative. A lot of people don't recognize that right away, but especially if I rewrote that kind of backwards, it'd be secant u tangent u, then we got the dx. But let's figure out what this dx is going to equal. So we know du dx, if we were to take the derivative of that original relationship, is just 10. So that means 1/10 du is equal to our dx. So right here I need a 1/10 and a du. Okay, so here's where this is actually way easier than you would think. The derivative with respect to x of secant of x is secant x tangent x. So if this is all in terms of u, we're looking at secant u tangent u. So that means the antiderivative, if we're to go backwards, is going to be secant x. So the antiderivative of secant u tangent u is just secant u. We got that 1/10 constant, so I'm going to keep that tagging along. And then plus c. Now in this case, u is equal to 10x. So we got to do 1/10 secant 10x and then plus c. Let's see, what do we got going on for this next one? All right, this is not as obvious, but it's still there. It's not completely obvious, but it's still there. I know that there's something with secant and there's something with tangent, and going one way or the other when I take the derivative, I get something squared. Well, let's think about this one. If I were to try and take the derivative of secant, that would give me secant x tangent x. But then I'd still have a tangent left over because I got two of them here. But if I have the derivative of tangent, that is secant squared x. So that tells me that this secant squared x dx is probably going to be something to do with my du. Then my u is going to be wrapped up in this piece here. I know it's not obvious, and a lot of it comes from seeing this problem more than one time. But I think if I use tangent x as my substitution piece, then I would have the integral of u squared times secant squared x dx. But this du dx, when I take the derivative, it's going to be secant squared x. And that's where I get the secant squared x. I'm going to multiply both sides by dx. So du is secant squared x dx. It's a perfect fit. So that means I'm really just doing the integral of u squared du. Now again, simple power rule, u cubed over 3 plus c, which is really tangent of x cubed over 3, or 1/3, however you want to write it, plus c. Done, 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 done. Okay, now these ones are almost easier. That last one was probably the hardest one you would see, and it gets slightly easier. Even though you would think it was harder with the algebra, it's really more about finding that substitution to set up. So let's look at this one. We got sine of x and cosine of x. Cosine of x looks like it's in a double layer, so that's going to be our substitution. So u equals cosine of x. That means I'd have the integral of sine of x. That's still in terms of x. Then we got u to the 1/2, because this square root is really 1/2 power. And we have a dx. So I got to get rid of this sine of x and this dx. Well, let's work our way through the derivative of that equation. Du dx equals negative sine of x. I don't want this negative, and I want the dx over there. So I'm going to multiply both sides by -1 and by dx. So it gets rid of that negative. And these dx's are simplified. We have -1 times du equals sine of x dx. And that's what we wanted. We wanted this sine of x dx. Those are the two pieces we needed. So I need to put in then -1 and a du. So I'm going to have the integral of -1. And we got u to the 1/2 and du. So taking the antiderivative of this, the -1 just kind of tags along. We're going to add 1 to the power. That gives us u to the 3/2 over 3/2. It's that process. Then plus c. Simplify this a little bit with the algebra. It's going to be negative cosine of x to the 3/2. And it was over 3/2, so that's really negative 2 over 3 plus c. See, that wasn't hard at all, because when you notice that there's layers, it kind of tells you which one is going to be your u to substitute. So let's look at the last one here and wrap this up so we can post this video. We got the 1 minus sine x here as a double layer. It's inside the square root. So we'll deal with this cosine of x eventually, but let's start with that. That means that u equals 1 minus sine of x. So now if we're going to make the substitution, we'll still have cosine of x over u to the 1/2. And then we got a dx. So the cosine of x and the dx are still an issue. So let's take a derivative and see what we can do with those. Du dx, the derivative of 1 is 0. The derivative of negative sine is negative cosine. And we want to move the dx over and take this negative and put it on the other side. So I'm doing a little bit of fast algebra there. That means that negative du equals cosine of x times dx. So let's rewrite everything. This u to the 1/2, we're going to bring that up. That's really u to the negative 1/2. We have a negative du, so we need a negative in there, and a du to get rid of the cosine and the dx. Now we can take the antiderivative. So power rule, the negative stays, it's a constant, it's really negative 1. U to the negative 1/2 becomes u to the 1/2, and it's over 1/2, plus c, of course. In this case, u was 1 minus sine x, so we're going to have negative 1 minus sine of x, all to the 1/2, or square rooted. And that 1/2 in the denominator actually winds up flipping, becomes a negative 2. We got plus c. There we go. We are done. Thumbs up. Happy face. Stars all around. Remember, watch the video again. Go over the problems. Check the homework. Come with questions into class so we can go over and rehash whatever you guys need. Thank you, and see you tomorrow.